Welcome to On Microsoft. Conversations with thought leaders in Microsoft technologies.
Good morning, my fellow Americans and citizens of the world. I'm here to announce an economic rescue plan for software development worldwide. I'm Sam Guckenheimer, just joking. I work at Microsoft. I am responsible for the strategy for Visual Studio Team System. You can think of me as our chief customer advocate. I came to Microsoft 5 years ago because of the vision of what's become VSTS. I'm happy to say that we're showing at PDC this year VSTS 2010. And we've taken that vision of focusing on the end-to-end flow of application lifecycle management. That is, thinking about what happens from a business decision to implement software to the realization of that value in the running software. And we've extended it. A lot of my colleagues here at Microsoft are brilliant at thinking about latencies in milliseconds and microseconds. With Team System, we're trying to attack the latencies that are measured in weeks and months across the development of software. Let me give you a couple examples of things we'll be showing at PDC. One of our emphases in VSTS 2010, you might have heard this under the codename Rosario, by the way, is to make every bug actionable. It's not about giving testers the ability to file more bugs. It's about giving them the ability to make every bug they file actionable. So when a tester clicks File Bug, all sorts of data is gathered up for free with that bug. You have an action log of every step that was taken leading up to that bug. That's indexed into a video file that lets the developer see exactly what was seen on the screen at the moment it was filed, along with a log under the system, a trace, that lets the developer launch into a historical debugging session. What do I mean by historical debugging? I mean that you can take the incident that was observed at the moment of fault and start stepping backwards through a code view or jumping backwards through a code view. What's the last time this particular member variable changed its value? Let me jump to the code there and then step forwards or backwards as though you were moving the remote on a TiVo machine. That's not all. From that same bug that I open, I can click, if I'm using the lab capability of VSTS 2010, I can click and open up virtual machines that were running the distributed system at the time of failure, checkpointed to that very moment. So I can, as a developer, attach to the machines at the point where the failure occurred. This is no longer a process for the developer of trying to set up an experiment. It's no longer about making the right initial conditions so that I can recreate what might be hinted at from this vague description that someone sent me in the bug report. This is about having everything at my fingertips in order to dive directly into what happened. And because we've added Symbol Server into TFS, you can get a code workspace matching the exact branch at the version where the fault was observed. This is the kind of thing that takes all the ping pong out of trying to understand reported bugs. That's where it starts. Now let me take it further. So suppose I then make a change to the code to fix that bug. Well, today I'd check it in and it would go into a build stream, probably with continuous integration. But we've taken continuous integration further. That check-in goes through a process that we call gated check-in. So instead of going into the main code stream, it goes into a private workspace on a build server that does a get latest on all the other source, adds my changes to it, runs through the compile, runs through the BVTs, runs through the code analysis, and applies other policies. Examples of those policies that we introduced in VSTS 2010 are things like architectural validation. What does that mean? Well, that means the build can catch things that, like bad dependencies, bad layering. How often do you discover your codes become unmaintainable because you or someone else introduced something that violated layering and you created, without knowing it, a cyclical dependency? Or maybe just a call across layers, like you went from presentation to database without going through the middle tier. That now gets trapped. It gets trapped for you dynamically, and it gets enforced for the team as part of the build validation, as though it were another unit test. And you can then click from that failure to see a diagram that shows you the layering, shows you the dependencies, lets you look at where you might have violated it, and click from there into the code. And instead of having to browse from this code file to that one that's being called, to the third one that's being called behind that, you can just right-click and generate a sequence diagram. And it shows you all the calls through however many layers across their lifelines, and you can see exactly where the problem is, and then fix it in the code. And if you're not sure, by the way, whether you should be fixing it, you right-click again, and you see the history of the change sets that went directly behind that. So you've got this flow from the build automation, which drives the heartbeat of the process, through to the architecture, to the visualization, to the change history, to the correction, that lets you prevent those defects in the first place, not just find them in the wild after they've occurred. And when they do escape, you've got all the information to debug off of the instance that actually occurred, the one that actually occurred, not the one you have to painstakingly recreate with your debugging experiment. Now, this is an example of the kind of end-to-end flow that I talk about in my book as value-up software engineering. The idea of value-up is that we focus not on things we do in isolation, drawing a model, running a test, but we think about the flow to working software in small batches, continual improving increments, working software delivered to a customer. And we think about that as a continual progression. And we use this friction-free data collection to squeeze the latency out. We use it to provide transparency across the team. We use it to troubleshoot things that can go wrong in the project. And we use it to ensure that we're getting quality at the beginning, and we're squeezing all of the messy, error-prone workflow out in the middle. We're delivering faster and at lower cost. I described that process in my book, originally for Visual Studio Team System 2005. We've been building on that with every release and with our quarterly power tools. You can see the latest things this year at PDC.
For more information, visit onpodcastweekly.com and subscribe to all our podcasts. Brought to you by the publishing imprints and information portal of Pearson Education.